Hi, I'm Damien Leonard and welcome to this course on ESP Gauges. As an engineer focused on artificial lift and production system, I've always valued the critical role downhole gauges play in understanding well behavior and protecting ESP equipment. They are not just optional add-ons, they are essential tools for diagnostics, optimization, and extending the life of the entire ESP system. That's why I've created this course, to give you a clear, practical understanding of ESP gauges, how they work, how they are integrated into the ESP system, the signal transmission principle, and how to choose the right configuration for your well. Here is how the course is structured. The section 1 deals with monitoring fundamentals and sensor design. In this opening section, we'll cover why ESP gauges are necessary and what they actually measure. You will learn about the main monitoring parameters, such as intake and discharge pressure, temperature, motor and intake, vibration, and current leakage. We'll also dive into sensor design. Our sensors inside the gauge translate physical phenomena into measurable signals, and the technical characteristics that define gauge accuracy and reliability. In the section number 2, we'll discuss system architecture and components from downhole to surface. Once you understand what is measured, this section will walk you through the full architecture of an ESP gauge system. We'll examine all major components, from the downhole gauge module to the surface chokes and electronics panel, and how signal transmission works from deep into the well up to the surface. You will understand not only the hardware, but also how the system is built to deliver reliable, real-time data for monitoring and control. Section number 3 is about calibration, troubleshooting, and testing. In this section, we focus on how raw gauge measurements become usable downhole data. We'll learn how the electrical signals coming from the pressure, temperature, and vibration sensors are converted into engineering units using the calibration coefficients supplied by the manufacturer. We also cover the most common issues that can lead to the loss of signal, such as grounding issues or gauge failure, and how to identify the source of the problem through a troubleshooting procedure. In the section number 4, we'll cover advanced gauge technologies and special configuration. This final section looks at advanced options and technologies that go beyond standard gauges. You will learn about innovations like double redundant downhole sensors, discharge temperature measurements, downhole flow meters, ground fault immune design, and digital gauges. This will help you select and apply gauge configurations tailored to complex or challenging well environments, enhancing monitoring precision and system reliability. Throughout the course, you get a balanced manufacturer-agnostic view. The content combines theory, practical insights, and detailed visuals, equipping you to evaluate gauge performance, ensure data reliability, and choose the appropriate gauge configuration for your ESP system and well conditions. Thank you for joining. I look forward to seeing you in the first lesson.